Hi, my name is Jason Park, and I'm here to propose a new work on video description that relies on adversarial methods during the inference. Here, we're given a sequence of visual events from the same video, and our task is to describe them using multiple sentences. For example, we show the first clip in the video, and a human describing a man hosting a news segment, followed by people riding down the river. We then show the next clip from the same video describing people falling out, and the last one showing more shots of people falling, but described in a slightly different manner. So here, we want our captioning model to sound like these human descriptions, which are visually relevant, linguistically fluent, and also diverse and coherent across sentences. Now, if you look at the prior works, we can see they can somewhat describe relevant activities, such as people riding down the river. But they still have content errors by describing events that do not happen in the video, or the sentence itself is not linguistically coherent by repeating phrases or having a fragmentation error in the sentence. And also, they tend to generate repeating phrases, unlike human descriptions, or even the entire sentence throughout the descriptions. So our main contribution is to avoid these errors and make it sound more like those human descriptions. And here, our approach tries to do so by being visually accurate without repeating content, and also pointing out interesting details, such as rough river and people shown in slow motion. Now, to understand why prior works suffer from these issues, we first look at typical approaches to the captioning model, where they're trained using maximum likelihood estimation objective. And during the inference, it uses greedy max or beam search to decode the most probable sentence. But the problem with this setup is that MLE tends to favor frequent n-grams in the training set, and also uses a limited vocabulary, as seen in the previous example. So due to these problems, prior works have explored generative adversarial networks to get more human-like descriptions, where the main idea is, along with training the generator, it's going to train its own discriminator separately. And in the joint adversarial training, the discriminator feedback is used to update and improve the generator using adversarial loss. And the inference follows the same setup. But again, the problem with GANs is that stable training for text generation is often difficult due to text being discrete output space. So here, we propose our approach called adversarial inference, where the main idea is keep the pre-training of discriminator, but actually skip the joint adversarial training. And instead, during the inference, rather than using greedy max or beam search, the generator will sample several sentences from the video and feed it to the discriminator, where now the discriminator job is to choose the best sentence from this set of candidates. And now on how to choose this best sentence, suppose you have generated a sentence from the previous clip due to our multi-sentence setting. And now we want to make decisions based on the three criteria discussed in the first example. And to do so, we train a thing called hybrid discriminator, which is a set of three discriminators separately evaluating on those three properties. And specifically, the visual discriminator looks if a sentence is visually relevant to the video. And we see in the first sentence, there's no kayaking in the original content. So the visual discriminator assigns low score to it, while keeping the others as they're visually relevant. Then our language discriminator looks if sentence is linguistically fluent. We see the second sentence, it repeats the phrase raft in the large raft, which is not fluent, so it gets penalized. And the pairwise discriminator looks if two consecutive sentences are diverse and coherent. Here, it filters the third one as it contains the same content from the previous sentence. So combining the three discriminators, our hybrid discriminator chooses the last sentence as the best one, completing our adversarial inference stage. So for our results, we report scores on the ActivityNet captions and compare our approach to MLE, GAN, and single discriminator design from prior work. Here we have the meteor scores at the paragraph level, and we see that ours has kind of comparable results. But what we want is the captions to be more diverse and less repetitive as human description. And here, ours does so with the highest vocab size, increased language diversity, and also less n-gram repetition. And most importantly, we perform human evaluation, doing better and worse than MLE, and we see that ours has the best human ratings. So the main takeaway is that our adversarial inference does better than joint training, and our hybrid discriminator outperforms a single discriminator design. So this was our work on multi-sentence video description. If you have more questions, please visit our poster session. Thank you.
If there are any questions, there are 2 mics on either sides.
I have a question for the third speaker. I wonder if feedback from the discriminator can be used during decoding, for example, by helping beam search, or if it's only applicable to the final generated sentences.
I think you can probably use it to beam search as well. And I think beam search, though, tend to have more constrained sentence space. So if you want more diversity, it might be recommended to use sampling. And here, I didn't mention in the talk, but we also use low sampling temperature, which tend to give more safer captions. So yeah, I think our paper has more details on that as well.
Any more questions? Let's thank the speakers again.